Good morning to all. In last class we talked about different circuit and we revisited some of the basic concept of carry look ahead error and then higher level. So, in the last class I told I will be talking about memory subsystem from today onwards, but in between what I decided to cover, that is something called floating point arithmetic. So, in last class we talk about the whatever the circuits, everything we talked on the fixed point number. Now, this class we will cover on what is called is floating point arithmetic. So, we will know how that subtraction or addition or multiplications happen in case of the floating point number. Okay. And next class also we will continue this topic, but little bit different, that is something called is the rounding off or normalization cases. Okay. So, we started with the topic that is something called floating point arithmetic and then book is Stallings. Okay. So, in last few classes we saw how the floating points are represented in computer system. Let us say we have a number x, it has two parts, that is, if you remember, that is mantissa and then exponent. Okay. So, let us say we have that mantissa is excess or significant into, and then we have the base and then we have the exponent is x e. So, in previous term this can be written as s x and x e. Okay. So, first part is significant and then later part is something called the exponent. Then we have another number, let us say this is y s into b to the power y e. Okay. So, these are the two numbers if we have, and then how do you perform the addition, subtraction and so on. Okay. So, if you want to perform addition, what do you do it? We can add only the significants if both is having both are having the same exponent. So, therefore, what we can do it, either we can represent the exponent in the smaller number, whatever the smaller number has, otherwise we can represent the other way, the higher number which has the highest value. Okay. So, here what you do it, we will put the exponent for the you just check out here what you do with s x into b to the power x e, okay, minus y e plus y s, and then b to the power y e. Okay. So, this is minus y e plus y e. So, it will be the same number and then we add y s. Okay. So, essentially we are converting the smaller number into the exponent of the larger number and then we add the significance. Similarly, we do x subtraction y is same as x s and in case of the multiplication, what do we do it? We multiply the s x into y s and then exponent, we add the exponent. Okay, that is we know earlier, and x y is we just divide y s, okay, and we subtract okay. So, this is for division, this is multiplication, okay, and this is subtraction and this is addition. So, one example, even though you know, but here in computer system how do you do it, that we will see using flow chart. Okay. So, let us say we have a number x equal to 0.3 into 10 to the power 2 and y we have number 0.2 into 10 to the power 3. Either what we can do it, we can represent this y as the exponent of 10 to the power 2, that is a smaller number, but general practice what we do it, we will represent the number into the higher number exponent. Why we are doing so? Because if you shift on the right side, because this number itself is smaller. So, if you lost one number in the right side rightmost position, so your loss will be minimum among these two. So, therefore, what is done is here, first we can convert it, x plus y is 0.3 into 10 to the power 2 plus 0.2 into 10 to the power 3. Okay. So, here 0.3 into 10 to the power minus 1 plus 0.2 into 10 to the power 3. So, this is what you will get it 0.03 plus 0.2 into 10 to the power 3. That means 0.23 into 10 to the power 3. This is nothing but similarly x minus y, what will happen? This is 0.03 minus 0.2 into 10 to the power 3. Okay. So, this will give you minus 17 into 10 to the power 3. Okay. So, actually multiplication division is much easier with compared to addition and subtraction. As you can see, is multiplication is nothing but you just multiply the two significant, you consider them as a fixed number, and we learn so many algorithms for multiplication. So, you apply one of them, and when it is done, then what you do it, you simply add the exponent, and obviously you have to normalize. Okay. Similarly, here you know the division, we learn it, and then you subtract the using simple subtraction technique, adder subtraction using fixed point number subtraction method. So, you subtract it, and then we have to normalize the number. So, therefore, any operation, that is addition, subtraction or multiplication or division, it has four basic steps. Okay. So, first is for we learn for addition and subtraction. So, it has four basic steps. So, first is phase number 1 is something called check for 0. So, it is something called phase 1 check for 0. That means, whether x or y, any one of them is 0 or not. If one is 0, then obviously answer will be the other one. So, that is something called check for 0. Then phase 2, align the significant. That means, if no one is 0, that is x or y both are not 0, or any one of them is not 0, then what is that? Now, you have to align the smaller number, you have to align the smaller number, that is significant of the smaller number with the adjusting or shifting the number either in the left side or small side, or the left side or right side. You have to significant portion you just move on the right side or left side, and accordingly you decrement the exponent or increment the exponent. So, based on that you align the number, and then phase 3 you add or subtract the significant. and then after addition again you need to do the normalization. So, that is something called normalize the result. So, it has 4 steps. First you check for 0, then is align the significant, and then you add the significant and then normalize the results. So, in earlier case if you say x equal to 0.2 into 10 to the power 2 and then it was y equal to 0.3 into 10 to the power 3. So, first is x is not 0, y is not 0. Then what you have to do, align the significant. So, here is 10 to the power 2, here is 10 to the power 3. So, you have to align the significant such a way that both the number will have the same exponent. So, then how do you align it? So, if you move on the right side, okay, so you will get 0, 2 and then it will increment, 2 will be incremented by 3, 1. So, it will be 10 to the power 3 and this side you keep it same 0, 3 into 10 to the power 3. So, both are same. Then what is the next step? Add or subtract the significance. So, this is addition. So, then you add 0.02 into 0.3. So, then you have a 0.32. Then you have to normalize, but there is okay. If you this is into 10 to the power 3. Now, if you want to normalize it in terms of 3.2 into 10 to the power 2. So, that we will write in flow chart here. Here we go. Have something z equal to x plus minus y, either subtraction or addition. So, first if it is subtraction, okay. So, if it is subtraction, then what you have to do? If it is x minus y, what we said ki it is equivalent to x plus 2's complement of y. Okay. So, then we change the number, we will take the 2's complement. So, change sign of y. So, if we want to subtract it, change sign of y. Sign of y means actually you should take the 2's complement. Okay. Now, you check the number x is 0, this is we are talking about y, whether x is 0, if x is 0 then result is nothing but the y. So, if x is 0, if this is the case, then z is the answer. So, z will be the y. Now, if we want to add it, asking x is 0, if it is no, this is yes, if it is no, then whether y is 0, if it is yes, yes, y is 0, then answer is x. Okay. Now, neither of them is 0. Okay. that means now you have to perform the align, that is phase 2, align the significand. So, now first question is whether exponent is equal. If it is yes, then we can directly move to the phase 3. So, now first question is exponent equal. If it is yes, then we have to do some other operation, that is you have to add it. If it is no, then what you have to do? The smaller number you have to move on the right side. So, increment the smaller exponent. So, if this is the case, increment smaller exponent. Because if it is 2, 3, so then we are moving to the higher exponent. So, it should be incremented by 1, and what is the case? Significant should move on the right side. So, that is significant, shift significant right side, shift significant right. Okay. Now, if shifting, let us say you have a number 0.001, if you shift on the right side, then this will be 0, right. So, this number will be 1, that smaller number will be 0. So, therefore, you have what you have to check, whether this significant is 0 or not. So, next is significant is 0. If it is 0, then other number will be the results. So, put other number. In Z. Okay. And then end. If significant is not 0, but whether it is aligned, whether the exponent of the both number is same, so that we have to check. So, this is here. If it is not, exponent is not same, so let us say we started with 2, x is having this one and y is having 10 to the power 4. So, then again we have to proceed one more step in this part. Okay. If it is not the case, then what? Now, we move to the yes, both are exponent at same. Now, what? Phase 3. Okay. So, if the exponent is equal, then we should add the both the significant. So, here add significant. Because we have changed, so only we have to do the addition. Now, after addition, what may happen? Ki significant is 0. If it is significant is 0, then what you have to do? You have to result will be 0. So, here question is significant is 0. If yes, then result is 0. Okay. If no, then we should move. There is a chance that significant overflow, that means result will be 1 point something. Okay, we are talking about significance. So, let us say we have 0.9 and 0.9. If you add it, so it will be 1.8. So, this is also overflow. So, if that situation come, then what you have to do? You have to again adjust the exponent. So, therefore, next we have to check significant overflow. Okay. Then what you have to do? Shift right. If it is yes, shift right and then increment the exponent. Okay. Now, if you increment the exponent, there is a chance that exponent overflow. Okay. So, therefore, if it is exponent overflow, then report overflow and then end the results. So, report so even the exponent is not overflow, then exponent is not overflow, significant is not significant is overflow, then we increment the exponent. Okay. So, now exponent is not overflow, then result is there. So, now you have to normalize the results. There may be a chance that we have results 0, 0, 9, okay, but not overflow. Okay. So, then you have to again. So, if it is no, then we have to move. Okay. So, if it is no, then we have to normalize. So, here, so result is normalized. So, if it is normalized, so that is the final results. So, results. So, if it is not normalized, then what you have to do? Shift significant left. So, it is not normalized. So, again you start shifting on the left side. So, this was the exponent part. Now, significant part you have to shift left. So, here is shift significant left. Okay. When you are shifting significant left, then what you are doing? You have to decrement the exponent. So, now you are decrementing. So, there is a chance that exponent might be a underflow. So, here exponent underflow. Okay. If it is underflow, is exponent is underflow, we cannot represent that number. So, therefore, if it is yes, then report underflow and stop here. Now, if it is no, exponent is not underflow, then what you have to do? Then again you normalize the results. You keep on doing here. So, this is for the addition and subtraction. So, but you better to you remember the 4 phases I told in the last slide, that is check for 0 and then align the significant, add or subtract the significant and then normalize the results. Okay. For normalizing the results, so many steps here we follow here, this step. on the rightmost position. On the other hand, that is multiplication and the division is much easier. Now, we will talk about multiplication. So, multiplication, as I said, if the number is xs into this is x and you have a number y, then what we are doing? We are multiplying ss into ys, and obviously we will do some what is called is move on the right side or left side, we adjust. Okay. So, before doing so, one thing I must share with you, one is something called base xe and base ye. What we are doing? We will do bxe plus ye. But if you do in computer system and IEEE 75 format, if you use it, then what happened? That base is already represented into bias exponent. That means, xe is nothing but exact exponent plus bias k. Similarly, y is something called exact exponent plus bias k. So, that is the bias exponent. These are represented in bias exponent. Now, when you add this number, that is xe plus ye, then what will happen? Xe plus ye, that is for the multiplication we have to do, that is let us say 10 to the power 3 and 10 to the power 2. But if we represent in bias exponent, so 10 to the power 3 plus k, 10 to the power 2 plus k. So, actually what should be the value? Actually it should be, if you add it, it should be 10 to the power 5. Now, what happen if you add this number, then what will happen? Exact exponent of number x plus exact exponent of number y plus 2k. So, that bias is coming twice, but what we say ki exact exponent will be encoded into bias exponent, that means exact exponent plus k, but it is coming twice k. So, therefore, after addition of these two exponent, what you have to do? You have to subtract k, then only we will get the exact value. That is we do in case of the multiplication. And in subtraction what happened? So, we are subtracting, that means this k and this k will cancel out. So, then to put the results into the bias exponent, so you have to add k. This is the only thing you need to remember. So, therefore, the flow chart is much easier here. Okay. Let us say we want to multiply x into y. So, let us say there may be a chance that one of them is 0, then results will be 0. So, therefore, x is 0, okay. If it is yes, then z is 0. No, results x is not 0, then obviously you have to check for y is 0 or not. Yes, then results is again z is 0. This is for check for 0, this part. If no, then we have to perform the operation. First easiest is we add the exponent. Okay. Here then that means if we add then we added the bias twice. So, then we have to subtract the bias. Now, we will check if you add it, add these two number, that is two values, okay, that two exponent. So, there may be a chance for overflow. Okay. So, therefore, we move for exponent overflow. Okay. If it is exponent overflow, the number we cannot represent. So, therefore, we have to report exponent overflow. It is exponent overflow? No, there is a underflow, because you are adding maybe two negative exponent. So, therefore, there may be chance for exponent underflow. So, therefore, exponent underflow. If it is underflow also, you cannot do anything, you cannot represent. So, therefore, you have to write key report for exponent underflow. If it is no, then only you can multiply the significand. So, multiply significance, both the significand. Now, whenever you multiply the significand, so there is a high chance that it will be what? So, it will be overflow of the significand. So, then you have to normalize the number and you have to adjust it. So, simply we can say is normalize. There is something called is round, that also we learn it round in the next class here, and this is end. Okay. So, this is for multiplication. So, next for we should have something called the division. So, if x is 0, then obviously we are dividing x divided by y, right. X is 0 means result is 0. If x not equal to 0, if y equal to 0, then we cannot perform the operation. Okay. So, x is, if y is 0, then we put something called infinity. Okay. So, let me write the flow chart here once more. So, for division, so here x is 0, yeah, z is 0. Okay. If it is no, then checking y is 0. If it is yes, insert z equal to infinity. Okay. And then obviously it is error. Now, you come to the point. What is that? Here subtract exponent, then k is wipe out, that is k is the bias. So, you have to add the bias. Okay. Next is exponent overflow. If it is exponent overflow, then you cannot do anything. So, report overflow. If it is no, then exponent underflow. If it is yes, then you have to report underflow. If it is no, then you divide the significant. Okay. Next, you have to normalize. And then round we will be covering in the next class, and then this is the end. So, with these we learn how to perform the addition, subtraction, and then multiplication and division in floating point arithmetic. In the floating point, if the numbers are represented into floating point number, floating point format. Okay. So, as you see in the last two cases like multiplication and division, we need to do round off. So, we will invest one more class for how to do rounding in case of computer system. With this note, I conclude today's class.